Okay. Well, good afternoon. Let's give a couple of minutes for people to trickle in. And as people trickle in, please remember that everyone will be muted. But of course, if you have questions during our presentation today, feel free to use the chat if that is enabled for you, or the Q&A if that is enabled on your end. At the end of the presentation, of course, we will have a time to ask questions, but feel free to make this as interactive as possible if the chat is enabled for you. Okay, it's 2:02, so I'm gonna get started so not to waste too much time. So just starting with the intro and some announcements. Of course, next slide. For those of you that are new and not familiar with the repository, our mission, of course, is to facilitate the sharing of data in biospecimens and other resources that we have available to the broader scientific community. We support the receipt and distribution of these resources in a manner that is ethical and equitable, and we try to make that as efficient as possible. We enable investigators from the broader scientific community that are not normally involved with the projects that submit resources to us to test new hypotheses without the need to collect news or resources. We look forward to make these resources fair and trustworthy, and we have been supporting these investigators for over 23 years now. We have a lot of resources, including imaging, clinical data sets, and biospecimens. We have supported over 100 investigators. We have weekly users that surpass 4,000 investigators and have over 7,000 registered users. Results from this publication, from these projects are over 900, and I encourage all of you to please visit our website if you have not done so recently. We have recordings of these presentations and many other things on our website, and the QR code is here so that you can get a direct link to our website. Next slide. So I'm very excited and thrilled to be presenting today. We have been talking for a while about our analytics workbench and the environment, and today we will be demoing our workbench. But the version that we will have today is the 1.0, but of course the future state will look differently. But the goal of this is to have an end-to-end data science lifecycle and a discovery space where we will merge, right, data scientists and clinicians. Well, our workbench is a cloud-based analytic environment where we will be able to promote collaboration, support AI innovation, and minimize data movements. This comes at a very timely time where enhancements to data security requirements have been coming, and many of our investigators are needing a space to continue their data analysis. So we hope that this is a place where they can continue those research analysis. And I would like to encourage everybody to please explore what we have to offer. And as you explore this, please feel free to provide us feedback because we would like to continue to improve our resources. Next slide. We are making this up as part of a series of webinars where we bring experts from the community. And today's webinar is, of course, as I mentioned, is going to be specifically about our workbench. We have many other topics that are intended to train our secondary users. These are held usually on the last Thursday of every month, but of course they can change depending on the availability of our speakers. The next one is going to be held on May 28th. It's planned from 3 to 4 in the afternoon. Next slide. And today I am happy to present our experts for the day. It's going to be Vivian Tran, who is currently serving in our team. She's a front-end developer and user experience designer from Booz Allen Hamilton. And she works with complex request processes and turning them into intuitive user-centered applications. And she helps scientists and researchers to easily discover and access resources. Also, we have Emma Luker, and she's a data scientist also with Booz Allen Hamilton, where she focuses on education and machine learning in data science applications. She works on aspects of healthcare spanning from medical imaging and processing to population health. She has supported the NIH Office of Data Science Strategy in creating cloud-based data repository and analytic platforms for public health research. So without further ado, I leave it up to the experts to take and present the data analysis that they will be handling today.
Okay, thank you,
Vivian?
Rebecca. Okay. Let me make sure this is all set up. Okay, so like Rebecca mentioned, today we're going to be showing a demo of the Workbench request process and then the Workbench workspace. So we'll be demoing from our test environment, so all the information you'll see today will be mock data. We'll start on the home page as a logged in requester, and to start a Workbench request for a specific data request, we're going to look in the topmost navigation bar and click on My Approved Studies. This will lead us to a page that has a list of our approved data requests. We can click on one of them to expand, and we'll see a drop-down for Workbench actions, where we can then start a Workbench request for this data request. At the top of the request form, there is a link to a Workbench user guide, and you can use that to reference as you fill out the form. On the right-hand side, there's also a modal where you can add or view comments and questions, and NIDDK staff can also reply back to you here as well. So the first question of the form asks you to select the type of workbench. Currently, we only offer SageMaker Studio, but in the future, SaaS will also be an option. So for now, we'll select SageMaker Studio, and then we'll have to select a computing size. For each computing size, we're showing the instance, the CPU, processing memory, and price per hour. If you need any help selecting the computing size that will best suit your research, you can always reference the user guide here. Next, we'll add in the target workbench start date. So we'll do end of next month. It asks for the time period or how long you'll be using the workbench for. We'll put 6 weeks. And the estimated usage per week, we'll just say 20 hours. You can also select additional users who will need Workbench access. So this list will be coming from users associated with the original data requests, such as your authorized organization representative, independent collaborators, and approved users. We'll select this person. And then we ask about the analytic purposes of the workbench. You can select all that apply, and we'll just select these two. Here we have a box that references the original data requests regarding combining data. So in this case, we had specified that we will not be combining NIDDK-CR data with other data sources. If that has changed at all, you can always click the link to modify your original data request before proceeding with requesting a workbench. Based on all the information above, there is then an estimated workbench cost range. And if you change any information, you'll see that the cost range automatically updates. So if we increase the estimated usage, you'll see the cost range is automatically updated as well. Moving on to the financial section, we have another box that shows the funding information from your original data request. We then ask if that funding support will cover your estimated workbench costs. If you select no, NIDDK will be reviewing your application and you may be approved for a workbench credit that can be used to cover your workbench costs. You'll then enter a cost estimate, and that cost estimate has to be within this estimated range above. So what I'll put for the cost estimate is $100, and you'll have to click the I accept this cost estimate checkbox. You'll then fill out the billing information. So I'm just going to put some mock data in here. Okay. So then what happens next? Once you're ready, you can submit the workbench request form and it'll be reviewed by the NIDDK team. If it's approved by the NIDDK team, a Data and Resources Use Agreement Cloud Use Addendum, or DUA addendum, will be sent out related to this workbench request. And once all the signatures are collected and funding is added to the workbench, you'll then be able to access the workbench. So here is an example of that DUA addendum. And at the very bottom is where all the signatures will be collected. And then here is an example of the invoice for adding funding to the workbench. Going back to the workbench request form, we'll submit it. And then, like I mentioned, once all the DUA addendum signatures are collected and funding is added to the workbench, you can come back to this My Approved Studies page. In this demo, we already have another data request that has an approved and active workbench. So then we'll go to that data request, and on the right side, you'll see this button that says Launch the Workbench. And then from here, I'll pass it on to Emma to show the Workbench workspace.
Thank you, Vivian. I will take over the screen so we can get into the workbench. All right. So once we are in the workbench environment, we can start up our workspace. So this workspace will already be pre-configured for your workspace, and this is a shared workspace that you and your team would share on the domain, meaning your other teammates approved on your study can see the work you're doing, and you can work with real-time collaboration. So I already started up this instance just so we're not waiting around. Depending on your instance size and file size, it could take up to a couple of minutes. So when we go into this space, we will see the instance size here. And that's the space, the instance size that I am approved for, as Vivian went through that approval process. And so should you discover down the line that you need a larger instance, you can submit a support ticket with justification, and you may have to acknowledge and accept any potential change in pricing associated with that resource. This is also a persistent space, so you will not lose any data when you start or stop the space. So when you click this Open Jupyter Lab button, it will open Jupyter Lab into another tab. For those that may be unfamiliar, Jupyter Lab is a web-based environment for creating interactive notebooks of code for analysis and data visualization. This is not an exhaustive tutorial of Jupyter Notebooks by any means. There are plenty of well-documented resources that are freely available on Jupyter Lab and Jupyter Notebooks. So once we start up the Jupyter Lab, it functions like the typical out-of-the-box IDE. So we have the default Python kernel. We also have R installed, as well as Glue PySpark pre-installed. But this environment also allows you to set up your own Conda environment or other packages that you can freely install, your typical pandas, scikit-learn. You can also run notebook jobs on a schedule. So when you open up a notebook here, so say you are getting new data every week, you can create a job and run that on a schedule. And so here we have all of these side tabs here. So we have the currently our home folder, which we'll go through in just a moment. Then we can see all of our terminals and kernels. So we can see the active notebooks that we have running here. We also had a terminal window open. We also have the GitHub extension that allows you to clone a repo, link your own Git credentials to manage your projects with your team. This collaboration tab will list other users approved on your team domain. I am a team of 1 right now, but the other online collaborators would appear here should you have a larger team. The table of contents will nicely display a table of contents based on your sections of Markdown in your open notebook. Then we have the data access tab here, which is for external data connections. However, this platform is for controlled access to the NIDDK central repository. So this feature is currently disabled. The extension tab, which holds all of your Jupyter extensions like a scheduler, and we have as well as a programming chatbot with all different models to debug your code. So if you go into the settings here, you can change the completion model. So this includes Bedrock, Anthropic, OpenAI, and you can even create your own SageMaker endpoint if you wanted to do some large language model development. So with this environment, you also have access to the AWS Registry of Open Data, which is a searchable data catalog of nearly 1,000 data sets, over 200 of which are life sciences related. So these data sets are comprehensively documented, often with example analyses and associated publications from many different institutions, including NASA, NIH Strides, and over 200 of which are life sciences related data sets. So if we search kidney, there is the machine learning for optimal detection of inflammatory cells in the kidney, or the monkey data set. So when we go into this data set, it will have a description as well as a link to the provider's comprehensive documentation, several usage examples, as well as their GitHub, and it will have the resource type and where the data are located. So each data set in the registry is associated with an S3 bucket where the data are located. So I can copy this link, which is the S3 bucket where it is located. I can come back here, open up a terminal, and I'll actually create a folder here called the monkey folder. And then I can type in the command to copy the data from the monkey training data set and make the destination the monkey folder. And that will start copying all of those associated files so that you can start practicing. All right, so you'll also notice here that we have all of these folders. So this is your home folder where you can upload data. So we have this upload icon here. If you have data locally that you would like to use this environment to analyze, as well as creating folders. But these source, working, results, and egress folders are central repository specific. So when you have studies that you requested data access to in the central repository, and those data access requests are approved, your studies will appear in your source folder, separated by each study. So this is a sample publicly available chronic kidney disease data set. This is actually from a Kaggle data challenge, which this was data over a 2-month period in India, which includes 25 risk factors or features of chronic kidney disease, including measures like potassium, sodium, creatinine, you name it. And so this is a freely available and downloadable data set, and there are plenty of examples of other users that have created classifications. So we'll see an example of that here. So when you have data sets that are approved, they will appear, as I said here. And when we go into each of these separated studies, we will see those data files associated with that study in the source file. Great. And then this is also synced to a folder linked to your account on the back end. So say you accidentally delete a file from this folder, you can simply resync this folder and it will reappear. So say you want to do some analyses with these data, you can set up your notebooks in the working folder here. And you can freely set up the structure how you like, and you can point your results. So say I did a bunch of data cleaning and wanted to save my progress there, I can write the results to here. And we'll just go through this example and this data set. So as I mentioned, with Jupyter Lab, we have this default Python kernel, but we also have an example here in R, so we can change this kernel up here, as well as changing it to PySpark. And so with this Python kernel, we can load in our appropriate libraries. We can look at our data sets, and we can start to do some data visualization. And so we can see with the out of the box chronic kidney data set, and we see a lot of these abbreviations. So if we wanted to get a better idea of the distribution of these variables, we can clean up these columns and clarify abbreviations, coerce the numerical values. And since this behaves like any Jupyter notebook, we can start to do some data imputation. We check those null values, remove our necessary outliers. And we'll also make this tutorial for freely available. This session is being recorded, as well as we'll provide this notebook so that you can have a chance to use it in the Workbench environment and get more comfortable as you get access to central repository studies. And so we can bring in our own Conda environment. So we can, once we do kind of the major cleanup here, we can start to get some nice data visualizations. Say I want to save this and maybe share it with my principal investigator. I can write this to my egress folder. So the other folder structures are a general best practice to keep your data organized. However, if you intend to download any data, whether it is to publish results or do some secondary analysis, downloading is disabled in this environment. So if you plan to download any data outside of the environment, you will need to place any of these data in the egress folder, and then you will submit a request to download these data, and the central repository support team will review the request and upon approval, deliver these data to you securely. This will also be included in the instructional guide, which will be available in the helpful information along with the Workbench request guide that Vivian showed earlier. So just to demonstrate a notebook, we have options to install different classifiers. So here we can start to see the different relationships of our target variables. So this is a general kidney disease classifier, and we can see how it's associated with the different risk factors in this kidney data set. And we can start to prepare some test data. So in this example, they provided a training and testing data set, which it's nicely split for you. And we can create and normalize these values since it does not take in categorical values. We can impute these data as necessary. And hey, I did all of this work to clean this data, so I'm going to save this for later. And then we can start to do some classification. So we already installed those libraries in that top cell, your typical logistic regression, support vector machine, forest, k-nearest neighbors, and we can start to examine the accuracy of prediction across these models. And we get 100% for a linear support vector machine, another 100%, and we can compare them at the bottom here and decide which model we want to use. All right, so before I leave, I want to shut down my kernels. So I don't have any runaway costs. So we can see all these different kernels here, and I can simply just shut down all of my kernels. There is also an idle timeout. So if your environment, this includes your notebook as well as your general Workbench environment, there is an idle timeout. So if your environment is idle, meaning there's no actively running cells for 15 or 30 minutes, it will automatically be shut down so that you're not incurring unnecessary costs. We've all left our computer on overnight. So if you leave and come back, you can just simply restart. This will turn into a start instance. So you'll just restart your instance. But if you have a job running overnight, that will not be interrupted. The idle timeout just checks for no actively running cells, no active running code. So that will not be interrupted. So now we'll open it up to questions.
Emma, I don't see anything. Oh, go ahead.
No, please go ahead.
I was letting Emma know that there was nothing on the chat, but please.
Yeah, so this is Rob Starp. So I unfortunately missed the first 10 minutes, but the AI summary was actually pretty good. A lot of these data sets have been plumbed a lot by our investigators. To me, the more useful parts are combining data sets together. Is that at all possible at this point?
Can you repeat that? Is whether we can combine the data sets in the Workbench?
Can you hear me? Can you hear me okay? So yeah, so again, a lot of these data sets have been investigated by our investigators, either the original investigators or people associated with these large studies. But it's always seemed to me that more of the power comes from using this with some other data, and particularly data even within the NIDDK repository. So is it possible to combine, to look across several studies, or to combine studies together to look for some more novel kinds of things than just looking at one study at a time?
Oh, yes, but that depends on what sort of approval they receive. So it will be up to the investigator to seek approval for the combination of those data resources. But yes, it will be possible for them to combine those resources and analyze those in the workbench. It's only limited by their own imagination and the constraints of the informed consent. Vivian, can you put back up the request process on how they select multiple data sets?
I can pull up the screen, but the original data request would have to support that for the workbench request to then be able to allow for multiple studies. So in this box, we had from the original data request about combining data, whether or not you plan to combine NIDDK-CR data with either other studies from outside NIDDK-CR or even just within NIDDK-CR, but it'll have to originate from the data request before you can bring it into the workbench.
And what does that approval process look like?
So that is our routine approval process. Vivian, can you also show that?
I can do a quick demo. This is from our test environment, so let me re-sign in real quick.
Yeah, so Rob, that's our regular data access process. So anybody can request one or multiple data sets, only limited by the informed consent constraints. So the data use limitations have to be consistent with each other.
Okay, thank you.
Rebecca, it is Ravi. I'm just following Rob's question. Is there any federated way within NIH you can get the data, access the data to make analysis? I mean, if I go to db-GAP, I can get so many other data, right? Relevant data. So I think Rob's question makes sense because, why do I have to come here and go search everywhere? Why not I go someplace, common place, I can federate all the data and analyze in one place within NIH atmosphere?
Yes, we are exploring the federated access and also piloting the use of the repository workbench to analyze data that is held elsewhere and how we transfer the resources from other repositories into our workbench.
Thanks.
I can show the data request. So you'll first need to do a requester self-attestation. So just asking what type of data request you would like to submit. Usually it is just a regular data request. And then you have to select, meet these 3 criteria: that you're a permanent employee at your institution, that you have oversight responsibility for those listed on the research project, and then you're accountable for ensuring that all aspects of the data usage align with the terms of NIDDK-CR DUA and the institution policies. So once you submit that, there'll be about a 4 or 5 step form. You can just do a request name here. And this is where you would select as many studies as you'd like to access the data. So you can just select like the first 3. And I'm not sure how much of the form we want to go through, but you would go through adding things like principal investigator information, any other researchers like independent collaborators, your authorized organization representative info. And then we ask for more questions about the research project information, some policy compliance, and then you can submit that for NIDDK to review.
One thing that I just noticed was that postdocs can't do this. Can you explain why not, please?
Yes, we can. NIH changed its policy recently, and only the PI at a senior level can submit a request. It has to meet the definitions. They have to have supervisory authority or oversight over the team that will be working on the research project.
I see, but a postdoc could do the analysis, but needs to be supervised by a PI. Is that what you're saying?
Correct, that the postdoc could
Okay.
work as part of the team, but only the PI can submit the request.
So Rebecca, I posted a question in my chat. So just curious, if I go to dbGaP, I have the MCP, Model Context Protocol. I can access semantic search, get all the data, and I can use the AI analytics to get whatever the data I want. I'm just wondering, why can't you implement the MCP to this one to gather the data similar to this, make your work easier rather than doing searching and doing so many other things? I mean, we are in different time now, right?
I don't know if we have that feature. Emma or Vivian?
I give the Model Context Protocol with the agentic AIs connections. Each one can do its own work with the MCP.
I am gonna ask the team here because I don't know if we have that.
Okay. All right, thanks. Otherwise,
So,
thanks.
Emma or Vivian or perhaps Alexandra, do we have that feature?
Yes, we have search. We have our Study Explorer, yes. It's not like full-blown semantic search, but it is a search box and faceted browsing. Vivian, you can show it.
But the semantic search is not connected to the Workbench itself, correct? Because I think that's what he's getting at.
Right.
Is it
exactly
in the Workbench? The semantic search is on our regular website, but not on the platform for analysis.
Right. Not in the analysis, no. We didn't connect semantic search into the Workbench. But when you select study to request and then to use in your Workbench, you can use free text search. And we have some semantic search features, not as exhaustive probably, but we do have some features. And I believe it's very similar to dbGaP, what we have here.
As everyone else on the call is thinking about additional questions that they may have for the analytics workbench or NIDDK-CR in general, I am going to post our poll. If individuals could take the time to do that, that way we can, it helps shape future webinars that we have for the rest of the year.
please feel free to ask us additional questions. And if you had feedback or thoughts on how we can improve the platform, please keep them coming.
Yep, feel free to unmute yourself or put them in the chat. I can also post our support mailbox where if something comes to you later on, feel free to reach out to us via email. And then just as people are thinking through their thoughts, our webinar in May will be an office hours style. We are still working on the demo that we will be doing in the beginning of the webinar, but otherwise it will act more as like a Q&A session towards the end of the hour, where if you have questions about the request process or logging into the website or the resources that are available at NIDDK Central Repository, we'll have the support team available to ask those questions as well there.
Okay, then if there's no additional questions, then we can end early. And I'll give everyone time back. Okay, well, thank you very much. So we are very excited about this new feature, and hope that everyone can find it as thrilling as we are. Thank you.